Geometry, angle measures, and angle bisectors. Alright guys, in the first page, on this page of the notes, this is a warm-up, so what you should do is work on it. Give yourself about 2 to 5 minutes, whatever is your comfort level, and when you're done, unpause this video. So that implies that you should pause the video now. Okay guys, so I'm going to assume that you had already paused the video and worked on it already. So here are the answers, guys. For the first one, the answer will be is the drawing of angle PQR, as long as you put the middle Q as the vertex, we're good. So you could have had PQR, or you could have just swapped these two and call it RQP. It really doesn't matter to me, so it's okay. The second one, the name of this could be angle 1 or angle LKJ. Number 2, name the angle 2 in many ways as possible, which is AEB or BEA. But if you answered angle E, that is incorrect, simply because E, when you say angle E, is ambiguous. So which one are you talking about? This one, this one, this one, this one, this one, and finally this one. There are 6 different possibilities. So there is an exception to the rule. You don't always have to have the 3 letters. So in that particular case, for example, the first one, you could have gone with angle Q. So instead of calling this PQR, we could have named this or angle Q. That would have been okay. But then again, then you would not have the P and the R here. But if you had this first, then you could name it angle Q, and that would have been okay in this particular context, because there's no other way to understand than that particular angle. There's no ambiguity. Now for part B, 1B, you could have also called this as angle K, and we would have understood that you're talking about angle LKJ. So when there is no ambiguity, I prefer to use either the letter like this, or use the number if it's given to me, or I might even just label it there. Much later in the class though, not right now. You have to use what's on the graph. You can't just make stuff up. Now for number 3, however, the answer is 11/2 or 5.5. If you got it, great. If you didn't, we'll be doing this problem a little later on. Let's move on to the lesson, guys. Okay, so here we go. So we have some lessons to go through. So distance around the circular arc is undefined until the measurement unit is chosen. So we're going to use degree, and that's a little circle. That's a superscript above the number, right? So we have a unit for circular arcs, right? In an entire full circle, we say it's 360 degrees. What that implies is that 1 degree is what portion of the circle, guys? If you said 1 over 360, that is correct. Now, you might want to add to this particular thing over here. Could you add the angles here, guys? Angle, 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 angle. By the way, in lieu of writing angle, you may use the notation. So let's define what an angle is. What is acute angle? If you said angle that is less than 90 degrees, you'll be correct. And I drew in, just before I started recording this, the XY axes. I'm going to use that as a reference. You really don't need it, but I'm just using this as a reference, so you might want to draw that in. So in this particular case, for the purposes of this example, we are always going to put the first ray on positive axes, right? X-axis, right? So if you have one ray over there, the next ray has to be in the first quadrant, right there. right? Yeah. So if you can't touch this, right? So that will be an acute angle. So what is an obtuse angle? It is an angle that is between, that's short for between, 90 degrees and 180 degrees. If we put one of the rays on positive x-axis, the other ray has to be in the second quadrant. And so that angle right there is the obtuse angle. Okay. Or if you wanted, you could have gone this way. It would have been okay. Okay. But for the purpose of this example, I'm always going to put the first ray on positive x-axis. For the right angle, is when the angle is exactly 90 degrees. So when you say angle is 90, it implies that it is exact. I only say that as a just to emphasize it. Okay. In this case, it's going to look something like this. And what we do to denote that is a right angle is put a little box over here. So it looks like there's a little square in that corner, indicating that it's a right angle. Straight angle is when angle is, guessed it, 180 degrees if it's a straight line, right? So that is a half of a circle. And of course, 90 degrees is a quarter of a circle. Moving on, angle bisector is a ray that divides the angle into two angles that both have the key word here. This is the important part. The same measure, right? The word bi means two, sect means to cut or divide in this case, right? There is a shorter definition in that you could say a ray that divides the angle, an angle into two, what you could do here is into two equal, or if you want to use the fancy word that we're going to be using quite often from now on, congruent angles. So you could have ended it that way. So my computer tells me it's 4:30 as I'm recording this. Yeah. So we have in the figure BD, it bisects angle ABC. Then these two are equal to each other. But I want to point out something here, guys. Okay. This right here, what's the difference between this notation and this notation with M in the front? This is a name, right? This is the name of an angle. So if, such as, so in case of people, it might be people's name, like Tom or Jill, right? Now this over here is an indication of a measure. That's why we use the letter M. Or it might be a numerical value. Same thing, right? Value of an angle. So in case of people, such as, it could be Tom's or Jill's age. So it indicates a numerical value. So for those of you who are into computer science and like to program, you could think of this right here, the data type, as strings, right? Or a string of characters, hence the name. This right here, you could consider that its data type as a numerical value, okay? All right, guys, I wrote this ahead of time for you guys. So if S is the interior of PQR over here, we could say that these two angles add up to the whole, right? So that's exactly what I did. So measure the PQR, which is this, is the sum of these two, which represent as PQR, PQS, and the measure of SQR right there. Okay, so this is called an angle addition postulate. Remember that word postulate? It's a given truth, right? It's a inherent truth. Something that cannot be. It is so obvious. There need not be a proof because it's so basic that we assume it to be true, right? Anyways, Here we go. So for those of you who did it, great. You get to sit back and watch the way I would like you to have done this. And we're going to be utilizing angle addition postulate. So we know that they gave us the measure of KLM, and we know that it's made up, then the point N is interior of these two angles. This angle's right there, right? Between the two rays, I meant to say. So we know that these two angles add up to the whole. Okay, let's write that out first. By angle addition postulate, I'm not going to write that down, but it's angle addition postulate. We know that the measure of the angle KLM is equal to the measure of KL and then the interior point plus the interior point, and we continue on with M. We know that the KLM is 135 degrees, the measure of KLM is 47 degrees, and the measure of NLM is 16y degrees. Subtracting 47 from both sides, we get what, guys? 88, exactly. 88 degrees, which gives you 16y degrees. So the number inside that's below the degree sign is 88 and 16y. To solve for y, we divide by 88. Sorry, divide by 16. And that, therefore, will yield 11 over 2, or you could say 5.5. Now, the question is, how did I get there? Right, so this is what I wanted to show you. Some of you guys just like cross and put a bunch of names over there. I would rather not see that. It's just really messy and confusing. And what I would rather see is show that for you to show it's 8 times 11 over 8 times 2. And we know that that is equal to this. And then in mathematics, when you multiply something that's equal to 1, this one, it's 11 over 2. So this is not necessary here for me. I'll just show you really quickly. And then from here, you could just write 11 over 2. And if you feel comfortable with this, you could just think it. You don't have to write that. Whenever I draw a cloud, thought cloud around a group of work, it's an optional step, right? Okay, guys, there you go. And I wrote this out just in case, just to make sure that I did everything correctly. And here we go. That is 1.3, geometry representing and describing transformations. That we're going to do it in class. All right, so that is the end of lesson 1.2. And I'll see you in class, guys. And be sure to submit the annotated notes. Thank you.